or Python? Which one to learn? This is a very common question. And I think that as a data scientist, you should know both. Of course, you should be more proficient in one of them, but also know about the other. I personally prefer Python. And if you choose another data path, then Python is enough. But as a data scientist, you will need R because it has great statistical packages for you to use. And they are already implemented and they are very powerful. For both languages, we need to know how to handle the data. For this, we're going to use Dataframes. They are data structures that look like a table. They have rows and columns, but are optimized to deal with data. You will find a lot of functionality with these data frames and find an easy way to deal with your data. Let's take a look at them. We're going to start with Python, and for this we use the library pandas. We have the Pokemon dataset as an example, so we have to read the CSV, first importing pandas, and then reading CSV, Pokemon.csv. And we have here the data frame. It's a collection of rows and columns, much like a table, with the name of the different Pokemons, their type, their attack, defense, and other columns. This data frame consists of 800 rows, and not all of them are printed because it's too big. How to create a data frame of your own? You can create it using this construct of a dictionary and a list inside of it. Name, type, attack, and you can create a data frame of your own if you don't import it. Let's get some basic information on the pandas data frame of the complete one. By using .shape, we can get the same information we knew, 800 rows and 13 columns. What are the name of the columns? With .columns, we get them as an index object. It's very interesting to use info, to get the data types that each column has. For example, we have here attack is an integer, type 1 is an object, which most of the times is a string. To select parts of the data frame, we use subselections. For example, head selects the first 5 lines of the data frame. We can also select rows using this construct 10 to 15, and we get the 10 to 15 rows, excluding the last one because of Python. We can also select one column by using the name, for example here attack, and we return is a series, not a data frame, just a list of the attacks with a row number. If we select more than one column, we get as a return a data frame, a subselection of this data frame, and here I just select head to just show the first ones. We can also drop some rows, remove some rows with drop. We can define the rows we want to drop, for example 1, 2, 3, and then we have only the 0, the number 4, 5, 6, and so on. We can also remove columns using drop, but here we have to define axis equals to 1 and the names of the columns we don't want to drop. Here's a smaller data frame. We can also filter our data frame and select just according to one condition some of the rows. For example, I want just the Pokemons that have an attack bigger than 180, and we find 2 of them, very powerful. If we want to find the top 5 biggest, we can use the already programmed function n_largest. We want the number 5, the first 5 from attack, bigger attack. We get here the data frame, the rows we are asking for. Another way is to sort the values and read the first 5 lines with head. We do this with sort values, and we sort by attack and in ascending way, false, because we want first the highest and then so on. And then here we get the same response as before. Not only can we just subselect, we can also analyze it, what is happening. For example, if we use the function sum, we get for each column what is the sum of the numbers. Look that the columns that were not integers or doubles will not be summed up. If we use mean, we get correspondingly the mean value. And if we want just the mean of one column, we can just subselect it, want to select that column and then ask for the mean. There is a very
helpful function, describe, where we get all the information we want. We just describe it and we get, for each of the columns, which are numerical, we get the mean, standard deviation, etc., etc. We can also do operations between columns. For example, if we want to subtract the column attack with the column defense, we can just simply do it and then assign it to a new column. Here it is, the new column. We can also work on one column and, for example, multiply it by 2 and assign it to a new column. For more complicated functions, we can use the lambda functions from Python, and they are very helpful to create new columns from the existing ones. On R, we're going to look at the same functionality, but of course with different syntax of the data frames in R. Here we don't need to load any library, we just need to use read CSV and the CSV file. And here we have the table, again, the data frame of Pokemons. To create a data frame on R, we use the data structure data.frame and give a list of our columns, and then we have here a smaller data frame that I created. To get the basic information that we got before, we can use nrow and ncol to get number of rows and columns respectively, and the names we could get them by the function called names. The information on each column is given by the function str, and we get that some columns are integers and some other columns are factors, so different categories in one data. We can subselect as we did before with head. Look here, we don't do point head dot head, but we just use the function head. And to select the rows is a very similar construct as with pandas, but we need to put a comma here because we're saying we want these rows and we want all columns. We can select one column by using the $sign, and we get as a response a list, not a data frame, the same as before. To subselect more than one column, we use the construct of saying I want all rows and I want just these 3 columns. At the end, I add head just for visualization purposes. To remove some rows, we can use the same construct as before, but with a minus. I don't want these rows 1, 2, and 3, and we just have from 4 and so on. For removing columns, it's a little bit more complicated with pandas. We have to use an extra function called subset, and then say I select all of the columns, but these 2 columns, and we have a smaller data frame. We can also filter by using a similar construct as before. I just want the Pokemons which attack is bigger than 180, and I want all the rows. We can also sort them with the function order, and in a similar way get the first 5 most powerful Pokemons. When analyzing the data frame, there are not already formulated functions to get the sum of all columns, but we have to do it column by column. Of course, we can use an apply or lapply from R to get all the sum from all the columns, or the mean. For that fact, here we have just from one column. But there's this nice function called summary, and we get from each of the columns, even those that are strings, we get some information. For example, the names, how many of them, how many Abomas now are there in the data set? Or how many of type water? We have 112. This did not work in pandas. To operate between columns is very similar. We just need to say I want this column and I subtract it to this column and I assign it to a new column, which I call power. The same when I want to multiplicate one column times 2, we use just the construct times 2 and we can assign it to a new column. I want to point out that data frames are not the most optimized version of data frames. You can use data.table from R, which are faster and are optimized to work much better than data frames. But if your data is not that large, data frames do the work correctly.
There is a lot of syntax to learn. That's why I recommend you to have a cheat sheet beside you. Take your time when learning data frames, since they will be your major tool when dealing with data.